Hey there, miners! Have you ever wondered how temperature can be accurately measured? Or how can we create devices that respond to the changes in heat or cold? Well, wonder no more. Welcome to the exciting video on thermistors and temperature sensing. Now, miners, get ready to dig deep into the fascinating world of thermistors and temperature. Alright, miners, let's unlock the mysteries behind temperature sensing and thermistors now that our curiosity has sparked. Let's break it down. Thermistors are made of special materials that exhibit changes in electrical resistance as temperature varies. This phenomena occurs due to a unique composition of structure of these materials. We can see this in action using the Steinhart-Hart mathematical equation to relate the resistance of a thermistor to its corresponding temperature. Here's that equation. Let's discuss what this means. T is for temperature, R1 is resistance of the thermistor, R2 is the 10 kilo ohm resistor, and C1, C2, and C3 are all constants specific to the thermistor's material. Using a schematic diagram, we can actually see how these components are incorporated within the circuit board, which will help us understand the implications of the math. Alright, time to bring it all together. With our trusty breadboard and some clever coding, we can transform these mathematical equations into a functional temperature sensing system. But first, this is what we need. A thermistor, a breadboard, a power supply, kilo ohm resistor, jumper cables, and finally, our trusty code. Now let's assemble these components. First we want to grab our breadboard, and then we want to connect two jumper cables, one to the positive and one to the negative. After that, we want to connect the negative to the ground and the positive to our 5-volt section. Now what we want to do is take our resistor and connect it from our positive port to another port on the breadboard. Now we're going to introduce the thermistor, in which we would then plug it into our negative port and then in series with the resistor. Now we want to connect our digital connection to the A0 port right in between the thermistor and the resistor. Time to plug in and test. Now let's introduce some heat. Now as you can see, the code is showing us the temperature of the thermistor, and once I apply heat, as you can see here, the numbers start to go up. Here is a screenshot of the numbers as well as a graph that depicts the ranges of the temperature when it spikes with heat. In conclusion, the Thermistor Project has been an exciting and educational journey into the world of temperature sensing. By exploring the theory and mathematics behind thermistors, assembling the circuit on a breadboard, and programming the Arduino, we have gained valuable insights and practical application of temperature measurement. Thank you.